Hello everyone. Good evening, guys. I hope you people have joined here. Okay, so this session is about physics. As you know that you are having your exams on this Sunday, or few people might be opting for the next Sunday. So we'll be talking about that strategy, that what we should do, what we shouldn't do for this that exam that we are having as JEE Mains exams. Okay, so this session is for physics, where we'll be talking about that what was the last year cutoff marks, what was the last year question numbers from which chapter, how many questions had come up in the last exams, and last 3 years we'll be talking about, and different strategies that for particular chapter what we should do, which topics we should cover, what new things we should cover up, or what old things we should revise. So these are all the things that we'll discuss in this session. I hope slowly and gradually people are joining. So within few seconds, we'll be starting it. And so I'll be just giving 1 more minute for all of the people to join, so that uh, you shouldn't skip anything that we are discussing in this session. Okay, so if we talk about the chapters in 11th and 12th, so basically we are having these chapters as unit dimensions, error measurement, then kinematics, Newton laws of motion, friction, etc. So according to, if we go to the last 3 years, 2015, 16, and 17, so these are the number of questions that are come up in the exams, in JEE Mains exams. Like in unit dimensions, if we talk about particularly, so in last 3 years, we had total 4 questions, one in 17, two in 16, and one in 15. As you can see that we are having mostly one or two, maximum 2 questions from this chapter. Same as kinematics, 101, and Newton laws of motion and friction. So these are the number of questions that had come up in last exams. Okay, so after this, we are having work, power, energy, in which last year one question had come up, system of particles, then gravitational, rotational mechanics, like that. But what we should learn, so if we go chapter wise, which things we should cover up, which things we shouldn't cover up. So these are the things that we'll discuss. So if we start with kinematics, in kinematics, people are having some issues like, so one dimension motion, two-dimension motion, three-dimension motion. If I just take an example, just hold on. So one dimensional motion, we know that if a particle is going in a straight line, that we can say that the particle is in one dimension motion. If the particle is going like this, so this is two-dimensional motion. So this is 1D, this is 2D. If we take motion of a mosquito or motion of an aeroplane, that mosquito is going in random direction in 3D. It is not going in any plane, but it is going in any random direction. That motion is 3 dimension. If I just give you an example, like if v1, the velocity of first particle is 3 I cap, velocity of second particle is 3 I cap plus 2 j cap, and velocity of third particle is 3 I cap plus 2 j cap plus 1 k cap. So if I ask that among this first, second, and third particle, which one is having one-dimensional motion, which one is having two-dimension, and which one is having three-dimension, 95 to 98% of people opt out that this is one-dimension motion, this is two-dimension motion, this is three-dimension motion, which is wrong. How so? If we just draw the motion of second particle, obviously we know that the first particle is moving in one-dimensional motion. If we talk about the second particle velocity is something like this. So if we draw that motion, the second particle is moving like this. If you can see that this is a straight line motion, this x and y coordinates are assigned by us. So if I assign the coordinates like this is my x, this is my y, then you can see that the particle is moving in x. Similarly with the third particle. So these are the things that we should take care in this chapter, particularly in kinematics. Okay, so then if we move to the next chapter, Newton laws of motion and friction. In friction, basically I've seen that the people are having issues in friction, that if I apply this much force, how much friction will act, if I apply this much force, how much friction will act, like this. I'll just take 1 minute for this friction, which is very important. Let's say we are having a simple block and it is resting on a surface. Obviously the surface is having friction. Let's say the friction coefficient is 0.2 and the particle mass is 10 kg. So what is the maximum value of friction that can act? That is equal to mu into n is equal to mg, so 0.2 into 100, that is equal to 20 Newton. Now if this block is resting, no other force is acting on it, the value of friction, if this is force F, if force F applied is 0, friction will be 0. Because friction is that person who knows all the physics, and he is very intelligent. He knows everything about physics. If you apply 0 force, there is no requirement of friction, so friction will not act. If you apply 5 Newton of force, still the block will not move, but the friction will act accordingly, that will be equal to 5 Newton, because net force has to be equal to 0. So friction will also keep on increasing its value with the applied force up to a limit. If F is equal to 20 Newton, friction can act as 20 Newton. This is the limit. Now if I apply a force of 30 Newton, now the friction cannot exert 30 Newton force because its maximum value is 20 Newton. So friction will act as 20 Newton only because that is its limit. So friction will keep on increasing its value up to a limit, and that is the maximum value of friction that can act. So people are having issues in this, so you should take care of these things. Rest, if I tell you that if you haven't covered, let's say, a chapter and you are having 4 to 5 days remaining, so you shouldn't cover up those new things. You shouldn't start those new things. That is an advice. So you should focus on the old things, the old chapter that you have studied. You should revise them completely, because if you are starting a new thing, that thing will come up in your mind in just, it will take around 10 to 15 days at least, depending on the type of chapter. So I would suggest you, do not start a new chapter, do not start a new topic. If you have left something, leave it now. The things that you have already done, revise them completely. Try to just revise it with full sense, means solve questions, solve sample papers, like that, but do not take up new things now. So next things, then we are having, after friction neutron, work, power, energy. So you should know how to apply work energy theorem, how to conserve total energy. So while conserving total energy, you should know if there is any loss or not. If the energy is losing, we shouldn't conserve the energy. We cannot, because some of the energy is lost. If there is any friction coming up, if the friction is doing some work, so some of the energy is being lost. So just keep these things in mind. So can you conserve the energy here or not? So there are few things where you cannot conserve energy because some of the energy is being lost. So you should take care of that lost energy. Then gravitation, then system of particles. In system of particles, mainly we are having center of mass. Center of mass chapter is very important, because in mechanics, completely in kinematics, in mechanics, sorry, center of mass frame is very important. Many things are very easy when we are going in center of mass frame. So we should know where is center of mass located for different bodies. For that, I'll just give you a small trick for center of mass, to learn about center of mass. uh, First of all, cinema, time, Ritik, Roshan, Shri Devi. Okay, cinema, time, Ritik, Roshan, Shri Devi. What is this? This is a cone. This is triangular plate. This is hollow hemisphere. This is half ring, because obviously for full ring, the center of mass will be at the center. So half ring. This is solid hemisphere. This is half disk. So if we learn these center of mass for these bodies, they are very much important. Okay. Cinema time, Ritik Roshan, Shri Devi. Put this dash. Then now learn. 4, 3, 2. 2, 3, 4. 4, 3, 2, 2, 3, 4. Pi 8 3 pi. This is the extra thing you have to learn. Pi 8 3 pi. That's it. For cone, we are making it with height. For triangular plate with height. For hollow hemisphere with radius. For half ring with radius. For solid hemisphere with radius. For disk with radius. So these are the distance of center of mass from their points. So you should learn this. Cinema time, Ritik Roshan, Shri Devi. Okay. So these will help you a lot. Then the next thing is gravitation. In gravitation, we should know that what is the acceleration due to gravity if we move up from the surface, what is the acceleration due to gravity if we move down from the earth's surface. So you should focus on these things. The motion of satellite, the motion of two planets or star planet system, you should know this. In rotational mechanics, moment of inertia is the main thing. You should know the moment of inertia of a ring, of a disk, which are very basic. You should know this. Of a solid sphere, of a hollow sphere. So these are very much important. Of a rod, uh, moment of inertia of disk, ring, rod, hollow sphere, and solid sphere. So these are very important figures that you should know. The moment of inertia of these things you should know. And then we just relate everything with the moment of inertia. 90% of the things in rotational mechanics are related to moment of inertia. How to conserve angular momentum, how to conserve these things you should know. So wherever at a particular point, you are having net torque is equal to 0. There you can conserve its angular momentum. Because torque is equal to what? The rate of change of angular momentum with time. If that torque about a particular point, external torque about a particular point is 0, you can conserve angular momentum. So you should know this, where you can conserve, where you cannot. So find out a point where you can get the torque is equal to 0. So generally, wherever the force is acting on a point, we take that point. Because about that point, the torque of that force will be equal to 0. So we would be able to conserve the angular momentum of the body about that point because the torque is equal to 0. So these are things that should take care in rotational mechanics. Then after that, properties of matter, it is a simple thing. Yeah, rotational mechanics is important. Gravitation and rotational mechanics. 3 questions had to come up. And in the 15 and 16, 2 questions each chapter. Okay, for properties of matter, you should know that if Young's modulus, if we are applying a body, if tension is given to a rod, then some extension in the length will come up. So how to relate that? Like delta L is equal to L1 plus alpha delta T. Yes, delta L is equal to L1 plus alpha delta T. This is with temperature. Okay, that increase in the length with temperature. And second thing related with the Young's modulus in solids, this Young's modulus is equal to stress, that is force per unit area, divided by strain, that is delta L by L. So here also we can have the extension or compression in the rod or in any body depending on that if we are compressing it or if we are extending it. Okay, then next we are having SHM and oscillations. If a particular body is moving, oscillating about a position, then its motion may be SHM, it may not be SHM. But for us, for 99% cases for us, it will be an SHM motion. So for spring mass system, we should know how to find the time period. For any other body, we should know how to find a time period. Basically, simple questions are coming up from these chapters. Okay. Then in mechanical waves and sounds. So these are the chapters in which people are having bit difficulties for waves and sounds. For sounds, particularly if I talk about the Doppler effect, generally people are having issues in Doppler effect. For Doppler effect, we should be focusing on very simple thing. Let's say this is source and this is observer. The velocity of source is Vs if the velocity of observer is Vo. And the source is emitting sound with frequency F. So these kind of questions are coming up, that what frequency the observer is observing. That frequency observed by the observer will be equal to. Now I'll just write down V plus minus Vo divided by V minus plus Vs. I'll tell you what it is. Where V is the velocity of sound in air. Okay. Where Vo is velocity of observer and Vs is velocity of source. Now, if the observer is moving towards the source, the observer is trying to increase the frequency, so plus will come up. How f dash can be increased? If plus is coming up in the denominator. Observer is in the denominator and the source is in the denominator. If source is moving towards the observer, then source is trying to increase the frequency observed by the observer. So minus will come up in the denominator, because only minus in the denominator can increase f dash. Okay. So if observer is moving away from the source, observer is trying to decrease the frequency. So minus will come up in the denominator. And if source is moving away from the observer, source is trying to decrease the frequency observed by the observer, so plus will come up in the denominator. Source is in the denominator, observer is in the denominator. Just learn this thing, and accordingly put your plus minus signs, that if the frequency is being increased or decreased, like that. Okay. Then after that, we are having ray optics and wave optics. In ray optics, people are having issues that how to put the sign. Minus sign will come up or plus sign will come up. Basically, we should know the sign convention. Sign convention is very important in ray optics. If I take basic thing, basic sign convention, let me tell you. And it is applicable for mirrors, for lens, everywhere it is applicable. Let's say this is my principal axis and this is my lens or my mirror. Everywhere it is applicable. First of all, the direction of incident rays will be taken as positive. For 99% of questions, we are taking the object on the left side. So incident rays will be in this direction. So we generally take the right direction as positive. But if in an equation the object is on the right side and the incident rays are obviously coming up like this, so this direction, left direction, will be positive. So we should know that what is the direction of incident rays. So incident rays are important. The direction of incident rays is important. We should know that in which direction the incident rays are moving. So let's say the incident rays are moving towards right, so I'll take the right direction as positive. This is the first thing. Direction of incident rays is positive. Okay. And this is pole or optical center. Second thing, important thing, all the distances are measured from pole. All the distances are measured from pole. Okay, be it the distance of image, be it the distance of object, we'll measure it from the pole. Just see in this example. For us, in this example, right direction is positive. This is my object. So I will measure the distance from pole in this direction as I am moving opposite to the positive side. So direction is negative for the object. So the distance of object is negative. If my image is formed here, the distance of image will be calculated as in right direction, so it will be positive. So this distance of image is positive, whereas distance of object was negative. This is simple sign convention. Second thing, that which height to take positive, which height to take negative. Generally, it is related to the orientation of object. Let's say in this orientation, object is above the principal axis. Okay, so I'll take all the distances above the principal axis, all the heights above the principal axis are positive and below negative. If the object is inverted, then I'll take the downside as positive and the upside as negative. So it will depend on the orientation of object. So in this case, if the object is oriented toward upside, so I'll take upside direction as positive. So depending on it, the height of image is also positive. So these are three things. Third, height is positive if it is in same orientation as the object. So only these three things are for sign convention, and they are important because without sign convention you cannot do anything in this optics. After that, we are having wave optics. In wave optics, we should know how to find the power difference. Okay, and power difference is related to phase difference, like 2 pi by lambda into delta x is equal to the phase difference. Now, how to find the power difference? I'll take just simple example. Let's say we are having one source here and one source here. Two sources are separated out by a distance, and assume that distance is 4.7 lambda, S1 and S2. So what do we understand by power difference? First of all, we should understand this. Let's say we are having a screen. This screen is placed here. The phase difference the power difference tells us that what distance one ray has moved as compared to the other ray. So one ray, this is screen, let's say, and I'm talking about this point, which is in the plane of S1 and S2. So one ray is coming from S2 to the screen. Another ray is coming from S1 to the screen. If they both are meeting at this point, the ray from S1 has covered 4.7 lambda distance more as compared to S2. So the path difference between them at this point is equal to 4.7 lambda. Okay, so this is the meaning of path difference, that what is the extra distance moved by one ray as compared to other ray. Let's talk about infinity. If we go to infinity downside, the ray will be moving like this, because we cannot deviate it at some angle because it is moving up to infinity. So both the rays will be parallel. So both the rays are covering equal distance up to infinity. So at infinity, delta x is equal to 0. So when I'm moving I am moving from infinity to this point. Initially, delta x is equal to 0, and finally at this point, delta x is 4.7 lambda. So in between, somewhere delta x is equal to 0.5 lambda, somewhere delta x is equal to lambda, somewhere it is 1.5 lambda, etc., etc. So if my delta x is equal to lambda, 2 lambda, 3 lambda, I am getting maxima on the screen if my delta x is 0.5 lambda, 1.5 lambda, and 2.5 lambda, and so on. I'm getting minima on the screen. So depending on it, I can tell where maxima or minima is formed. I can tell how many maximas and minimas are formed. Like this, if delta x is 0 also, then maxima is formed. So at infinity, I'm having maxima, here minima, here maxima, here minima, and then maxima, and so on. So somewhere here delta x will be equal to 4.5 lambda. This is minima. So after this center point, I'll get first minima, then I'll get maxima. So depending on it, I can tell how many maximas or minimas are being formed. Okay. Then if we move to the next things, heat and thermodynamics. In heat and thermodynamics, we should know that how to draw the graphs between pressure and volume, between pressure and temperature for different processes. Like we are having isobaric process, isochoric process, adiabatic process. So we should know all the processes and how to find the work done. So depending on the work done, we should know how to find out the heat involved in the process and the internal energy. So we are having one formula, that is Newton's that the law of thermodynamics. That law of thermodynamics tells us that delta Q is equal to delta U plus delta W. So in physics and in chemistry, these things are different. In chemistry, they are taking the work done as negative, where we people are taking it as positive. So when the volume of the system is increased, if this is a piston, if there is any force being applied by the system, the volume will increase. If that volume is increased, we take the work done as positive. The work done by the system, we take it as positive, where chemistry people are taking it as negative. So you should know the difference. You shouldn't be confused. If the paper is of physics, you should know delta Q is equal to delta U plus delta W, where work done is positive if the volume of the system is increasing. Whereas in chemistry, you should switch your brain to work done as negative if the volume of the system is increasing. So you should be able to switch that. So depending on it, if we are having two things, we can find out the third thing. We can find delta U. So delta U is telling us about the internal temperature. If the delta U is positive, then delta T is positive. It means the temperature of the system has increased. If delta U is negative, the internal energy of the system has decreased. Basically, the internal energy of the system is related to temperature. Temperature is increasing, internal energy is increasing. If temperature is decreasing, internal energy is decreasing. That's it. Then after that, what else we are having? So we should know how to draw the graphs between pressure, volume, temperature, etc., etc. Then electrostats, the first chapter of 12th class. In electrostats, we should know the electric fields, potentials for different bodies. Basically, if we talk about electric field and potential particularly, one thing is clear. If there is any conducting body, let's say this is conducting solid body. Okay. So for conducting solid body, the net electric field inside a conductor cannot be positive or negative. Means it should be zero. The net electric field inside a conductor, it should be zero. I can give you a reason for that also. Let's say we are having external electric field. External electric field is there. So electrons will move opposite to it. So minus, 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 minus electrons will move opposite to it. So plus, plus, plus will come up like this. So there will be an electric field generated like this. Electric field is generated. If we talk about this point, external electric field is in this direction, and induced electric field, generated electric field is in this direction. So this electric field will keep on increasing until and unless the electrons are moving inside this body. So when this induced electric field has become equal to the external electric field, then the electrons will stop their motion and net electric field will be equal to 0. So this is the reason why the electric field inside a conducting solid body is 0. Then we should know that what is the electric potential, electric field inside a hollow sphere, inside a solid sphere. What is the electric field due to an infinite wire having charge density lambda? What is the electric field due to finite wire having charge density lambda? What is electric field due to any arc or due to any ring? And what is the electric field on the axis of a ring? Like this is my ring. What is the electric field on the axis of a ring at some distance? We should know all these things. We should know these formulas. And electric field due to dipole on the axis of a dipole, like here if I talk about this point A, and on the axis perpendicular to the dipole, that what is the electric field? We should know this. Okay, these are important things. The sphere, the solid sphere, hollow sphere, electric field due to it, electric field outside a solid sphere, electric field inside a solid sphere, and potential due to a solid sphere, potential due to a hollow sphere and solid sphere. So these are the things that are important. And one thing, internal energy is also important. That what is the energy of a system, potential energy of a system. If we talk about potential energy of the sphere, potential energy of the hollow sphere, solid sphere, like that, or potential energy in any system, let's say talk about this system Q and Q. How to find out the energy, potential energy of the system? So potential energy is basically the work done to make that system, that how much work we will have done to make that system. That will define its potential energy. So first let's separate out the system. There is no charge. Initially, we must have taken Q charge up to a point. Do we need to do some work? No, because there was nothing and I have placed only one charge. Leave it. We have to make this system. How we are making it? Like this. So we have put a Q charge here. Do we need to do work? No, because there was no opposition. No one has restricted it. So no work being done. Then we have taken out the second charge from infinity to this point. Let's say distance r. Now, do we need to do some work? Yes. Why so? Because due to this Q charge, there was some potential. And as we are moving against the potential, we have to do some work. How much work? Q into potential at that point. Because at infinity potential is equal to 0. So at infinity potential energy is equal to 0. So here we are having potential, due to which we are having potential energy here. That is Q into V. How much potential is there? KQ by R. So Q into KQ by R. So here we are having energy as KQ square by R. So this is the potential energy of a system, KQ square by R. Similarly, this is the basic method to find out the potential energy of any system. Okay. So this is all about electrostats. Then capacitor. In capacitor, let's say we are having any capacitor in a circuit. Let's say like this, we are having any circuit. Any 10 volt, 2 ohm, 2 ohm, and if we take it as, let's say 2 ohm, and this is capacitor. What is the capacitance? 1 by omega c. Now, if I talk about the time t is equal to 0, at time t is equal to 0, when the capacitor is also fully discharged, no charge is there in the capacitor, then I have switched on, I have completed this circuit at t is equal to 0. At time t is equal to 0, omega is infinite. If omega is infinite, 1 by omega is 0. So xc is equal to 0. Xc is equal to 0 means what? That at time t is equal to 0, this will behave like a straight conductor. It will behave like a straight conductor. So basically what will happen, the current will move to this side also and to this side also. So this 2 ohm and 2 ohm in parallel will become 1 ohm. 1 plus 2, 3 ohm. Total 3 ohm is the resistance. So current drawn will be 10 by 3 ampere. This is the story at t is equal to 0. Now at t is equal to infinite. Let's say the story about t is equal to infinite, what will happen? At t is equal to infinite, omega will become 0. 1 by omega is infinite. So Xc, that is capacitive reactance, will become infinite. If the capacitive reactance is infinite, it will oppose the flow of current. So the capacitor will behave like an open circuit. It will be like this, an open circuit. If the circuit is open, it is not complete, so no current will move in this direction at t is equal to infinite. So all the current will be moving in this direction. So now the resistance is 2 plus 2, 4. So current drawn will be 10 by 4 ampere at t is equal to infinite. So we should know that what should happen with the capacitor depending on its time. Okay, that will it become infinite? Will it become zero? Like that. That's what will happen to the current. Okay, then next thing we are having current electricity. Current electricity is full play of the resistance, and there also we are having instruments like potentiometer, meter bridge, etc. So basically it is just a play of potential, resistance in any circuit. These kind of questions may come up like, just hold on, like a circuit is there. We are having batteries, and some resistance are being connected. People like 10 volt, 10 volt, if let's say 2 ohm each. Then we need to find out the current, this I current. How to find that out? First we'll assume somewhere 0, that the potential is 0. If potential is 0 here, then I will say 0 here, then I will say 10 volt here, I will say 20 volt here, but I don't know that what is the potential at these points. So for that, I will assume x here, y here. If this is y, this is also y. Okay. Let's say z here. Then we have to draw the junction law that total current coming in will be equal to total current moving out. If we apply the junction law here, then total current coming in is Z minus 20 by 2. And total current moving out is equal to Z minus X by 2. So accordingly, uh, accordingly we can find out that what is the value of Z, what is, how it is related to X, etc., etc. Sorry, here it will be Z minus 20 by 2 plus total current moving out will be equal to Z minus X by 2, that will be equal to 0. Means total net current at a junction will be equal to 0. Whatever the coming in, that is the same that is moving out. So total current at a junction is equal to 0. So put that equal to 0, you will get relations. And like if I apply the junction law here, then X minus Z by 2 plus X minus 10 by 2 plus X minus Y by 2 is equal to 0. Net current at X is equal to 0. So we are having a relation between X, Y, and third equation will be from here. Like here in first, Y minus X by 2 plus Y minus 0 by 2 plus y minus 0 by 2 is equal to 0. So we are having relations with x, y, and z are three variables. We are having three equations, so we can solve for x, y, and z. Depending on it, I can find out that what is the value of I, because I know x and y. So when we are solving for this junction, we'll assume that the x1 is bigger than y. So I'll take everything with respect to x. When I'm solving for this one, I'll take everything with respect to y. So these things are being done like that. Then the next thing that we are having is magnetism and magnetic effects of current. Magnetism is bit related to electrostats. Magnetism is what? Means when the charge is moving with constant velocity, then magnetic effect is being raised. Magnetic field is coming up. Okay, so we should know how to find the magnetic field, or the magnitude of magnetic field at a point due to a infinite wire, due to a finite wire, on a ring, on the axis of a ring. Okay, so all these things we should know, due to a cylindrical wire, cylindrical hollow wire, and cylindrical, so solid wire. And we should know a formula, that Ampere's law, integral B dot dl is equal to mu naught I. So we should know this Ampere's law to find out the magnetic field for symmetric bodies. Where the magnetic field is symmetric, where for all the points on the Ampere's loop is constant. Magnetic field on all the points on Ampere's loop is constant. There we can find the magnetic field by using this Ampere's law. Ampere's law. Okay. Then magnetic effects of current, that due to a current is what? Current is the movement of a charge, and so due to current, magnetic field will arise. So due to that, we should know how to find the magnetic fields, etc. After that, we are having electromagnetic induction and alternating current, electromagnetic waves, and communication. So these EMI and AC are important among these. In electromagnetic induction, that if there are two loops, let's say, okay, these are two loops. If there is any current, we should draw it neatly. If these are two loops, there is any current in one loop and it is changing. So due to that change in current, due to change in magnetic, change in magnitude of that current, there will be some current being induced in the second loop. How to find out that direction? The direction is given by Lenz's law. Lenz's law says that the magnetic field will arise in such a way that it will try to make the effect of the thing that has produced it to be equal to zero. It will try to oppose the reason for its production. Let's say here, if we talk about here the magnetic field inside this ring is out of the plane, and outside the ring it is into the plane. So everywhere the magnetic field is into the plane, like this. If my given condition is that this current is increasing, so magnetic field inside this loop is increasing, into the screen it is increasing, but Lenz's law says that we have to oppose it. So if inside it is increasing, so we'll produce a magnetic field outside. So to produce a magnetic field outside, the current should be anti-clockwise. So an anti-clockwise direction current will induce in second loop. So in this way, we can find out the direction of current induced. What is the magnitude of current induced? That is given by Faraday's law. Faraday gives us the magnitude of magnitude of current being induced. Actually, it is giving us the EMF induced. That EMF is equal to minus d phi by dt, where phi is magnetic flux, d phi b by dt. So if I divide it by the resistance of the conductor, I will get current. So E is equal to minus d phi by dt. We can find the magnitude and the direction by Lenz's law. So this is the basic thing in electromagnetic induction. And same goes with the same means alternating current. For alternating current, we are having three type of appliances like inductor, resistance, and capacitor. How they are related to each other? If you put all of them in the circuit, I'll just take an example. Like if we are having everything in a circuit, this is inductor, capacitor, and resistance. They are connected to an AC source. Okay, I'll just take an example. This resistance is equal to 4 ohm. The capacitive reactance is equal to 3 ohm, and this inductive reactance is equal to 6 ohm. If E is equal to 10 sine omega t plus 20. So this is the question that is given to us. We have to find out that what is the potential across capacitor or the potential across inductor. So in inductor, the voltage is leading, and in capacitor, current is leading by the voltage. How to learn this? Learn CCL. In capacitor, current will lead. Capacitor current lead. Learn this. In capacitor, current will lead, and in inductor, voltage will lead. So for these kind of questions, we have to find the impedance. Impedance Z. Z is equal to under root of R square plus XL minus XC whole square. If you solve it, it will come 5 ohm. Okay, then we'll find the current drawn from here. That maximum value of that current will be equal to maximum value of potential divided by impedance, that is equal to 2 ampere. So I is equal to 2 sine omega t plus 20, but plus something else will also come up. What that else is, we have to find the power factor here. But before for a power factor, we should find out the phase. How so? That 10 phi is equal to XL minus XC by R. That it is 6 minus 3 by 4 is equal to 3 by 4. So 5 from here is 37 degree. Okay. So here XL is more as compared to XC. So this circuit is bit inductive, means voltage will be leading. So current of this system will lag by the voltage. By how much angle? By phi. If the angle of voltage is omega t plus 20, so angle of current will be omega t plus 20 minus 37. So current will be equal to 2 sine omega t minus 17 degree. But still we are not done. We have to find out the potential across inductor. How to find the potential across inductor? Basically, maximum potential across inductor will be equal to I naught XL. That is equal to 2 into 6 is equal to 12 volt. So potential across inductor is equal to 12 sine omega t minus 17, that is of current. But in inductor, the voltage is leading the current by 90 degree. So plus 90 degree. That is the potential across inductor. 12 sine omega t plus 73 degree. This is the potential across inductor. Whereas in case of capacitor, the potential across capacitor will be what? In capacitor, current is leading. So potential will be 90 degree less than current. This is the current minus 90 degree will be the potential across capacitor. And the maximum potential of capacitor will be 2 into 3, that is 6 volt. Okay, one more thing, important thing to learn from here is maximum potential, that is input potential, is 10 volt, whereas maximum potential across inductor is 12 volt. So LCR, this circuit is also used to increase the potential for a particular appliance. That's also why we are using this circuit. Okay, so this is about AC. What else we are having? Okay, then modern physics. Modern physics is very important because many questions are coming up from this modern physics. Since last 2 years, 5 questions are coming up from modern physics itself. So for modern physics, we should know the structure of atom, and then X-rays are there. Then then that theory of potential barrier, the theory of, like, if there is any metal, if I take an example, there is any metal whose work function is equal to 2 electrovolt. Okay, this is its work function. What do we understand by work function? That this is the minimum energy we require to take out any electron out of this metal, to take out any electron out of this metal. So let's say a photon with lambda is equal to 400 nanometer is tracking on it. Will it be able to eject an electron? One photon is coming up. So the energy of photon is related as 1240 by lambda electrovolt when lambda is in nanometer. So if we put it 1240 by 400, 3.1 electrovolt energy is coming up. Its work function is 2. So yes, we will be able to eject one electron out of this metal. Where is the remaining energy? That is 3.1 minus 2 is equal to 1.1 electrovolt. Where is that energy? That energy will be as kinetic energy of that ejected electron. The one electron will be ejected with kinetic energy of 1.1 electrovolt. One photon will eject only one electron. It's not like that. If that energy is, let's say, 800, if the lambda is 800 nanometer, then energy coming up is 1.55 electrovolt. This is the energy coming up with a photon. So one photon will not be able to eject one electron, but if there are two photons, then total energy is, let's say, 3.1 electrovolt. Will it be able to eject one electron? No. These two photons combinedly cannot eject one electron. Only one photon can eject one electron. So we'll talk about the individual energies of photon. Depending on it, we can say if an electron is being ejected or not. Okay. So this is the total theory about modern physics. So these are the things, these are the chapters, that what things we should learn, what things we shouldn't. So I have talked about these things depending on the chapters. Then next thing, that what was the cutoff marks since last 3 years. This is it. For general category, the cutoff marks is approx 100. It is decreasing since last 3 years. 105, then 196, then for OBC, the last year 68, for SC and ST 50 and 47 respectively. Basically, we should be able to score, at least I would say that if you are scoring 25%, then you are good. Then you are in selection criteria. But I would advise you to score a bit more. Obviously, everyone wants to score more. So if your score is approximately between 20 to 25%, then there are many chances that you'll be selected in JEE Mains. And how many people are able to write JEE Advanced? Last year, 220,000 people were able to go for JEE Advanced from JEE Main stage. If your target is JEE Advanced, then your rank should be in first 2 lakh, I would say, in first 2 lakh students. Then you will be able to go for JEE Advanced exam. Okay. Now, how to start the exam paper? Like, if I talk about my experience, that how to start, which subject we should choose first to attempt in that paper. Let's say there are three subjects, obviously: physics, chemistry, and maths. So whichever subject you are feeling that this is your favorite, that you can score well in this subject, uh, you should attempt that first. First, go with the favorite one. Second, go with the less favorite one. Third, go with the very less favorite one. So get the confidence out of the first subject. If you have attempted lot of questions and you have confidence that you have scored well, that everything is correct, then you will get some confidence, due to which you'll be able to solve for other two subjects very easily. That has happened with me, and that is happening with many people. And means if you are confident, then you can score well. So get that confidence out of the first subject itself, and then you can put that extra confidence on the second and third subject. Okay. And do not be in a hurry. If you are unable to get any question, the main rule and the simplest rule to get any question is read the question again. If you haven't got that what the question is asking, just read it again simply. But do not read it more than 3 times. If even after reading it 3 times you are unable to get it, just move on to next question. Do not waste your time on that one. You can come up to that question at the last part of your time. Okay. And if you're stuck in any question, and let's say you have wasted 10 minutes on it, do not go into deep. If you have wasted a lot of time, you are not getting anything out of it, just move to next question. Next thing, there is negative marking. Shall you go for hit and try method? No. If you are confident with the answer, and you can say that this answer is good, you are very much confident about it, you have solved it, only then attempt it. Yeah, second thing is, if your score is like 5%, if you are unable to solve any of the question, then shall you go for hit and try? Yes, then you can say that you can go with hit and try method, but I would not advise it. If you are scoring well, then you shouldn't go to any hit and try method. You should put only those answers which are confident, means you are confident about those answers. Second thing, people are able to solve questions, but only 15 minutes are remaining and they haven't filled any OMR sheet. No answer is being there in OMR. And in last 15 minutes, people are putting the answers. People are just circling them. That is not a good idea. If you have finished with one subject, just fill out the OMR sheet. I would advise you to fill it after every 10 questions. Because sometimes what is happening, let's say you are filling it for 11 to 20 question number, for 11 to 20 in OMR. If you skip one question in OMR or in the question paper, let's say that your answers are uh, that your answer that you are getting is A, C, D, B, D, B, A, like that, and in OMR you are filling it. First you have filled it as A, then you have filled it as C, and somehow you didn't see this D, and you have started with B, then D, then B, and then A. So your these answers will be wrong because you have skipped one question. So I would advise you to fill it the OMR sheet after every 10 questions. Sorry. But do not take it up to end. Just fill out the OMR sheet with the time. Okay, fill it. And best of luck for your exams. And we are just finishing it up. And no mark of any paper can decide your future. Be confident, prepare well. Thank you, guys.